One second. Let me make sure everything is set up and we will get started. All right. Hello, everyone. My name is John DeGos, and I am CEO of Golem Cloud. And it is my great pleasure today to kick off our first Bounty to Hire event. So, my company is, I think, fairly well known in the bounty space. We put out a lot of bounties. I think we've spent in excess of probably $60,000 incentivizing open source developers to work on issues that matter to the community. So, a couple of weeks ago, we decided that we needed to hire someone for our team at Golem Cloud, which is a 100% Rust project. Tons of exciting stuff. I'll tell you about that in a second. And it occurred to me that we might be able to do a 2-for-1. We might be able to put a very interesting technical ticket out there and put a big bounty on this ticket and then get a few people to give it a try and see what they come up with. And then hopefully, one of these people is going to be who ends up submitting a solution that satisfies the requirements of the ticket is not only going to win what is the largest bounty we've ever done by far, but also will be offered a job by Golem Cloud to join the Golem Cloud engineering team. So win-win-win. Contribute to open source, maybe win $15,000, and possibly even find your next all Rust job. Want to hear more? Is that exciting? Well, that's why you're here. Let's go ahead and dive in. I'm going to share my screen and walk through a brief presentation. And then I'm going to talk more about the requirements of the ticket at the end. And in a moment here, I'm going to give everyone a way to ask questions. All right here. So if everything is going well, you should be able to see my screen now. This is our Bounty to Hire program, which is kicking off today, October 11th at 12:05 Eastern Daylight Time. To begin with, there are 2 links that are very, very important. And I'm going to give you the first one because it's going to take you a while to type it in. This is a link to our Discord. This is a link to Golem's Discord. So I encourage you to hop on over to discord.gg/WGQUEZGR77X. So go there and say hello. And this is how you can ask me questions during this live stream. So if you've got any questions related to Golem or about what is entailed in this ticket or the rules or specification, clarifications, whatever, the way you ask those questions to me now on this live stream is by going to that event. This event is being live streamed across 4 different platforms. So you might be asking questions on LinkedIn, or you might be asking questions on Twitch or one of these other places, and I won't see them. So hop on over to Discord if you have any questions today. The second important website is, of course, the home on the web of the Golem open source project. And Golem is hosted on GitHub, and it is in the Golem Cloud organization. And furthermore, it is the Golem repository inside the Golem Cloud organization where you're going to find the bulk of the open source that is associated with this ticket, as well as the ticket itself, which I'm going to show you towards the end of this presentation today. All right, so you want a Rust job, or maybe you just want a $15,000 bounty. We don't care much. But in order to do that, you're going to be working on Golem. So it makes sense to spend at least a few moments talking about what Golem is. And a great way to think about Golem is as this next generation open source platform that allows you to build and deploy bulletproof backends. Okay, that's what Golem is we're all about helping developers build cloud native best practice backends that are bulletproof. They don't go down. And not only are they bulletproof, but you don't actually have to do anything in order to get these benefits. You can write very, very simple code, and your backends are going to be able to execute transactionally, which basically means that if there's something happening, some fault happening at the level of the server or the operating system or the hardware or whatever, your program is actually not affected because its state is being mirrored to other nodes in a cluster. And so if there is some sort of fault event, your program just continues execution on a new machine transparently. And this new paradigm, which is sometimes called durable execution or durable computing, allows you to build extraordinarily reliable systems with very, very simple code. And that's the gateway to understanding what Golem is about, is that we want to help you build the most reliable systems in the world just by writing ordinary simple code that looks like it's like impossibly simple because it's not actually having to worry about all these different failure scenarios that have led to the growth of event-driven architecture and led to the growth of projects like Apache Kafka and whatnot, and have led to very large-scale enterprise architectures that are very scalable and they're very robust, but they're also very complicated. And Golem is trying to provide a simpler way and say, hey, if you need an API that needs to be reliable, a new endpoint that needs to be reliable, if you need maybe you need a whole backend that needs to be reliable. If you have a workflow or a business process and that needs to execute over hours or days or weeks and it needs to be reliable, or maybe you have some sort of AI stateful agent or workflow or business process automation using AI, and you want that thing to actually execute reliably regardless of what is happening, and you want to just store stuff in memory, then Golem is providing a pathway to do that. Golem and all other solutions in this space of durable execution are providing a way to do that. Golem does this with an approach that I think is quite novel, and that is we take over execution. You actually execute your code on Golem. You compile your code to WebAssembly, which is a new standard that is, I think, gaining traction for back-end use cases. You compile your app to WebAssembly, and then Golem actually executes that WebAssembly in a special way that guarantees durable state and transactional execution and whatnot. So you don't actually need to use an SDK. You don't need to program to any kind of library. All you need to do is build your app and then run it on Golem. And we're doing this as all open source because we believe that the next major vendor neutral computing platform for building backends is going to be open source, and we want that to be Golem because Golem provides you that benefit of sort of, checkbox durability. Check a box, and boom, your service becomes instantly reliable in the face of any kind of fault. And so I encourage you to check out the website golem.cloud if you want to learn more about the sort of high level what Golem is about and how you build applications on Golem. And then also check out the official GitHub repository if you want to dive into the source code. And I certainly hope most of the people attending this live stream today are interested in checking out the source code and hacking on this issue that we've got this $15,000 bounty for. All right, so here's the timeline. October 11th, that's when coding begins. That is today. And I'm sure some of you have already forked the repository and are hard at work understanding how everything is put together. So congratulations, kudos to you. So you're going to have a little over 2 weeks, about 2.5 weeks, in order to work on your solution. And I recommend actually you do this work in private. Ordinarily, when you do open source development, you do it in public. But because of the size of this bounty is actually quite substantial, and we don't want to encourage people to take credit for your work or to derive their solution from your solution, I strongly, heavily recommend that you do all of your work in private. And then come October 28th, which would actually be midnight the day before on October 27th, you are welcome to open your pull request to the Golem repository containing your solution. And what I recommend you do before you open that pull request is to send me by email a zip copy of the source code. That way it totally removes any questions of who authored that code. Now, you build some code, you send me the zip archive to john@zyverge.com, and I will get that, And in the event there's any sort of contestation around who wrote this code, then you'll have that sort of archive sent to me as a system of record for arbitrating any sort of disputes that might arise in the event that we have someone trying to cheat. So just heads up. Beginning on October 28th, judging will begin. So that means October 28th and later, we at Golem Cloud, the judges of who's going to win this coding competition challenge, are free to merge any pull requests, right? So maybe you submit your pull request on October 27th at midnight, so on the very eve of October 28th, and maybe we decide to merge something right away. Why? Because maybe it satisfies all the requirements, your code is well written, it demonstrates deep understanding of the domain matter, you have unit tests, you have integration tests, you have system tests. Maybe you even went all out and wrote a few lines of documentation, so we didn't have to figure out all of this on our own. And we click that big merge button, well, congratulations, you have won. At that point, when we merge a pull request that aims to fix this ticket, then obviously we won't be merging anything else, and we will have already picked the winner of the bounty. So there's no guarantee, however, that we will do that on October 28th. Why? Well, because typically you submit a pull request to an open source project and it's 95% of the way there, but it's not all the way there. So we might have to say, hey, this looks great, except, I'm going to need a test here. Or maybe you should change this name to be this way. Or have you considered that this approach is not very scalable and it's going to have some trouble under load? So we may have some feedback for you on October 28th or October 29th, and it might take you a few hours or a few days in order to incorporate that feedback in your pull request. So even though we're free to merge on October 28th, we don't guarantee that we're going to merge a pull request then. And you might have anywhere from a few hours to a few days before one of these pull requests actually satisfies all requirements, and we feel comfortable saying, yes, this is the winning pull request. I'm going to merge this in because it does the job as specified. So there's incentive to submit on October 28th at the earliest possible moment, maybe the day before if you really want, doesn't matter to us. And also incentive, I think, to make sure that pull request is ready to merge. Right? Because if we do see one that's ready to merge, we'll just merge it. We won't wait around for other people to revise their pull request. We're just going to merge something if it's in mergeable state. So try to make sure it is mergeable state and that it checks all the boxes. And in any case, if you're not able to do that, or you do get feedback saying, hey, maybe you should tweak this, it pays to be on top of that, right? So if we comment at 2 p.m. on October 28th that it looks good, except you're missing one test, or, it looks good, except the CI is failing. Like if the build is failing, and that's the only reason why we're not hitting the merge button, then that's a good reason to be on top of it and make sure you investigate, figure out why CI is failing, and then go ahead and fix the problem so we can merge that in quickly. Now, on November the 4th, that's basically our own internal deadline. So what that means is we will pick a winner among all these pull requests. If there's 2 or if there's 3 or 4, 5 pull requests, we're going to pick a winner by no later than November 4th. And that's also when we'll publicly announce the winner. Not that we'll need to announce it, because the merging of that pull request, of course, will trigger the bounty payment through Algora. That's our partner who we've used for all our bounties across all of our open source projects. We'll be using them to pay out that bounty. So the merging of that pull request will trigger that. But no matter what, November 4th is the day we'll go public on LinkedIn, and various other places saying, hey, congratulations, so-and-so, you are the winner of the $15,000 bounty. And then we do intend to interview the winner, obviously, but also maybe a few other people. I'll talk about that in a second. And to have all those interviews completed for anyone who wants a job. Obviously, we know some people are going to participate in this and they're already happily employed. Congratulations. Yeah, I have no desire to change that unless you want to change, and I'll certainly try to talk you into that if you win this bounty. But that said, we do want to make a number of interviews, and we want to have all of those completed and wrapped up on November 11th, so we can go ahead and send out at least one job offer, maybe multiple job offers, depending on how things go, to candidates by November 11th. All right, so that's the timeline. What is the structure of this bounty to hire event? Well, first off, there will only be one winner. So it doesn't matter how many pull requests we get, if it's one or if it's five, only one of those will end up winning the $15,000 bounty. So make sure it's yours. If you're going to invest a few weeks of nights and weekends in working on open source, do a good job. Make sure that you win this, because we only have that one $15,000 bounty, which we will award in its entirety to the solution that we believe and determine satisfies all the requirements in the way that we want those requirements to be satisfied. Now, that said, if you submit a pull request that contains an all original solution, so you didn't derive or copy that from someone else, if you submit such a pull request and it's reasonably complete, maybe it's not all the way there, but it's mostly there, then we do guarantee you an interview. Okay, we respect your time, and if you're going to be investing your time into contributing to great open source projects like Golem, then you're definitely someone we want to talk to. So if you submit any pull request and your code is original and it's reasonably complete, we want to talk to you. It's not necessarily to say we would extend you a job offer, but we still want to talk to you and get to know you, because we will definitely try to work with you at some point in the near future, either through bounties or through job offers or who knows what. But that is there for you to rest secure in. And then finally, we are actually hiring. So this is not just about bounties and open source development. This is about us satisfying a need that we have for a Rust developer to join our team and work on Golem, which is an open source project, full time. So this is lots of greenfield stuff, lots of amazing sort of next generation open source platform-based development, very complex, meaty problems. If you like distributed system engineering, if you like highly scalable and highly reliable design, if you like building developer tooling, if you're very motivated to if you've built, like many, cloud native applications, so-called cloud native with all the best practices, and you see how monstrously complex it is to make applications that are reliable and also scalable, and how monstrously complicated it is to deal with caching and databases and events and serialization and HTTP protocol and gRPC. If you see all that monstrosity and you're inspired by our vision to totally reinvent the fabric of cloud computing for the next generation of applications, then, come join our team, right? We will be, it's very, obviously the winning bounty and everyone else who submits a pull request, we could get very unlucky and maybe none of you will be looking for a job. But assuming you are looking for a job and assuming you complete this solution, we will be making at least one hiring decision. And even though we have a preference to hire the winner of the bounty to hire event, that's not a guarantee, right? Because the winner might not be looking for a job, or the winner might be looking for a job, but they might want compensation package that we can't offer being a startup, or they might not be a team player, right? There's all sorts of things that we have to make sure, boxes we have to check after we do these interviews. But it is our intention to make at least one hire from the pool of candidates who have submitted original and reasonably complete solutions, with our preference being to hire the winner of the bounty, because of course there's probably a reason that they won, right? Their solution is better in some way, so our preference is to hire that person if it all works out. Fine print. What do we have here? Well, number one, and maybe somewhat surprisingly, no help. We will not help you in your solution. And that's a difference from normal open source development. I'm an open source author. I'm an author of a bunch of projects, and I am very hands-on. I help with people. Sometimes I pair with people using Zoom. So I want to help people ordinarily, but in this particular case, we are not offering any assistance, right? No help in any way. And that also differs from your experience joining our Golem engineering team. If you join the Golem engineering team and you get blocked, then obviously your colleagues are here to help you level up, help unblock you, help show you around the code base. So all of that is expected if you were to join the Golem team member. But for purposes of this bounty to hire event, we are not offering any assistance. So don't bother asking questions because we won't answer them. And the exception for that is if you need clarification on the specification only, then ask on the GitHub issue. You ask on the GitHub issue, and I will personally get back to you and clarify the specification. Don't ask that on Discord because it will be lost. We need to save that because it could benefit other people who are participating. So if you have a question about what this means, or if something should be done in this way or this way, if there's a choice, a sort of fork in the road, then ask on the GitHub issue to clarify what the requirements of this ticket are, and I will personally clarify that. But don't ask about how to build it. Don't ask about how to download Rust. Don't ask about Rust compiler errors. Don't ask about where to find some file. If you have to ask those questions, you're not going to be able to complete the ticket. And if you have to ask those questions, you're probably not a fit for joining the Golem team. So unlike real world open source contribution where we will help, because this is a special event with a $15,000 bounty and a job offer, we're not offering assistance, and it's important to understand that. Number two, no cheating. And the primary thing that we're looking out here for is to make sure that your solution is all original, right? It's just not ethical. It's not a moral thing to do to copy from someone else's solution. So we're trying to take some precautions by encouraging all of you participants to build this in private. But that said, we don't know for sure everyone will build in private. So some people might be building in public. It doesn't matter. You should not copy or derive your solution from other developers. Your solution needs to be 100% you. Okay. And if you were to work with a team of developers, okay, then to solve this issue, you need to be upfront about that. Because even though a team of developers might be able to finish this issue, there's no way we can stop that from happening. So, right, we can't stop a team of you from developing this solution and one person submitting it as their own. We can't stop that. So a team of you might be able to complete this, and you might be able to win the bounty, but you're responsible for splitting that bounty. And obviously, we're not going to be doing job offers to a team of people who are working on this. So I encourage you to do this on your own and maintain high standards of professionalism. Don't copy from anyone else. Don't take your inspiration from anyone else, etc. And the other thing that we will be very, I think, aggressive about is if you use AI to build a solution to this, a full solution, and I don't mean Copilot helping you autocomplete a line. I mean, you use an AI agent or otherwise try to use AI to build a full solution. First off, it's not going to work. I guarantee you it's not going to work. It probably won't even compile. But if you do that and you submit that as a pull request, then you're wasting our time and we will ban you from the project. There'll be no further collaborations with you if you end up wasting our time by submitting one of these AI-generated solutions. We've seen them in the bounty space. We've done enough bounties to know that a lot of people just go in, they grab an AI agent, they hope it comes up with something that's close enough, they submit that pull request, and it ends up wasting our time. And there's no tolerance for that in this event. So please do not do that. Otherwise, you will definitely not be working with us in the future. And then finally, this is a rule, no way to enforce this one, but please try to have some fun. Golem is a really fascinating and very sophisticated and advanced open source project that's really trying to do something incredibly ambitious here, reinvent the very fabric of cloud computing. And there's so many interesting, meaty problems to work on in this open source project. So please try to enjoy yourself, have a little fun. Open source should be fun. It's something that we do, many of us do nights and weekends. So we should have a good time and we should take pride in our work. We should do things our way, right? Open source is about us doing things our way because we don't have a boss to answer to. No one tells us how we're going to spend this evening or this weekend. So we can take the time to do things our way. We can take the time to choose our architecture, our algorithms, and so forth. And we can take pride in our work. And we can also take pride in collaborating with fellow open source developers. I know all bounty projects like this have a tendency maybe to be a little bit competitive, especially when the bounty is as high as this one. But still, I think there's a lot of opportunity for personal growth and learning and development. And if you really do invest into this project, if you do end up submitting something, or even if you don't, right? If you just become familiar with the source code base, there's going to be a lot more opportunities in the future, either to work on other bounty tickets that we end up putting up. This is the first bounty we've done for Golem, but not the last. There'll be a lot more in the future. And then also, we'll be hiring in the future too, right? We're hiring now. We need to satisfy our requirement for adding to the Golem engineering team, but we'll be hiring in the future. We'll be doing a lot more bounties in the future. So even if you don't get this particular one, if you become familiar with the source code, if you get engaged and energized by our vision for the future of cloud computing, if you invest into learning what durable execution is about and how Golem is put together enough that you can contribute at some level, that will be valuable to you in the future and hopefully enjoyable and personally and professionally rewarding for you in the future, just having leveled up a bit and expanded your professional network. All right, y'all ready? Get set, go. It's time to get contributing to open source. So what I'm going to do right now is I will take questions on Discord, and then I will walk you through the ticket. And if you have any questions, more questions generated by that walkthrough, then I will answer those. And then I will bid you good luck again, and I will probably see many of you on Discord. So let me go ahead and open up Discord. I will stop sharing my screen for the moment. And I will open up Discord. And see if we have any questions. Well, hello. There's a lot of people to say hi to. So hello, everyone. Good to see you all. Wow, there's a lot of people here. Fantastic. Wow. Okay. And then we have a so-called noob question. How is Golem different than Kubernetes? Well, that's a really great question. I think Golem actually uses Kubernetes, right? We actually use Kubernetes for deployment because Kubernetes is really an operating system for distributed applications and platforms. And in as much as you could use, like you can use Kubernetes to deploy Redis or MongoDB or something like that, a piece of cloud infrastructure, you can also use Kubernetes to deploy and manage a Golem cluster. So in that respect, they're totally compatible. And you might say, well, Kubernetes is designed to help you deploy and manage and supervise applications, and that's true. And so there is a little bit of similarity to Golem, but Golem is really concerned not with images, with Docker containers, not with containers of any kind, right? It's concerned with so-called WebAssembly components. So basically what Kubernetes does for containers, Golem does for WebAssembly components. But it's not just a matter of sort of supporting deployment and monitoring and all that stuff, which of course Golem does, but it's also a matter of executing these components in a way that gives you bulletproof guarantees. What do I mean by that? Well, let's say you open up your favorite web framework and you implement some sort of checkout API. And as part of this checkout process, you've got to reserve inventory in the warehouse. You've got to process the user's preferred payment method. You've got to dispatch, you've got to generate a shipping label. so that you can have something to print out and track the package as it's in shipment. You have to dispatch the order to the warehouse. You've got to send the user email confirmation. You've got to do all these different things. If you stand that up using your web framework of choice and deploy it on AWS or whatever, then lots of things can go wrong. Why? Because as your process, as your API is in the middle of executing, after it's done part of those steps, but not all of them. So after it's reserved inventory and charged the user's credit card, but before it's printed the shipping label and dispatched to the warehouse and sent the user the email confirmation, then something could happen. And it could be the server dies because of out of memory or some other server error. It could be that Kubernetes kills the pod that's running your server. It could be that the operating system has a fault, blue screen of death or whatever. It could be that node was taken down for maintenance. It could be a developer pushed out a new version of an application. They were editing some config. They pushed that out and it interrupted your API midway through. And what do all of these, it could be CPU catches fire or something like that, truly catastrophic at the level of hardware. What do all these different fault scenarios have in common? Well, they interrupt a process that was never intended to execute part way. So in distributed systems, we go in and we touch this system and we update that system and we touch the database and we call this API. And we often need all of these things to happen transactionally. We need to be able to update multiple systems transactionally. And you can't rely on ordinary cloud infrastructure to do that. So Golem, unlike Kubernetes, right? Kubernetes doesn't actually touch execution. It doesn't execute your apps at all, right? It's the operating system that executes your app, and Kubernetes keeps an eye on it. Golem actually executes this sort of, bytecode of your application. And it does so in a way that guarantees if there is a fault event, then your running code is relocated to another machine and it executes from the exact sort of line of code that it left off on, right, where the failure event happened. It continues executing with no downtime. It gives you automatic fault tolerance. And even though there is overlap in Kubernetes, we view Golem as being very compatible with Kubernetes and Kubernetes as being the preferred vehicle for rolling Golem out into your own cloud or some off-the-shelf cloud. It's a great way to deploy and monitor Golem itself. And then another thing Golem does that I didn't mention here is if your app calls out to some database or whatever and there's some sort of fatal error involved, then Golem will retry that automatically, right? So you don't even see a lot of the cloud flakiness. Not only does like the machine that your program is running on become invincible, even though it might not be the same machine, right? Golem is moving it around if there's any faults, but it's like programming on an invincible machine. But also when you talk to other systems outside, if those things are flaky and result in errors, Golem tries to compensate for that by automatically applying retry strategies, retry policies that mean, yeah, you call that API, maybe it was flaky in real life, but your program never sees that. It just calls the API and it works. And so it basically isolates you from the flakiness of the cloud, as well as giving you this automatic fault tolerance that makes sure you can program on this ideal machine that can never go down and is always going to execute your code flawlessly to completion on every request. And then we have another question from Adria, which is, how does Golem impact the need for traditional event streaming systems like Pulsar? Could Golem replace both event sourcing and actor models in applications that need to maintain real-time state? That's a very intelligent question. I can tell you've worked in the space. So the answer, I think, is the industry is still trying to figure that out. But it's my own personal opinion, and I know the folks at Restate, which is another durable execution provider that's open source, have the opinion that basically event sourcing and event-driven architecture in general is almost like assembly language. It's very low level. And even though you can build very reliable applications using event sourcing, it is like working at the level of assembly language. There's all this serialization. You've got to build deterministic state machines. You've got to worry about codecs and versions and all sorts of things. Topics of how am I going to chop this up into different topics and so forth. And there's just a lot of things you need to worry about in order to build a very reliable, distributed, and scalable application using event sourcing. And solutions like Golem and Restate, they don't necessarily replace event sourcing per se, because in many cases they use event sourcing underneath, right? In Restate and Golem, you'll see event sourcing if you look down there, but it's just hidden away, right? And you as a developer no longer have to think in terms of event sourcing. You can just think in terms of, here's my business process. I want this to execute, and I'm just going to call functions, and I'm going to, sleep for 2 weeks, and then I'm going to send an email after that, and then I'm going to do this and so forth. And you're just writing ordinary imperative code, and it looks very simple, and it's going to be run reliably over any amount of time, and disasters are not going to get in the way of its execution. You get transactional execution, and you don't need databases as much because you're just storing stuff in memory, right? You maybe don't need a database at all. You just store all your stuff in in-memory hash maps and whatnot. And because the machine you're writing on, the virtual machine, is invincible, that's as good as a database. So Golem gives you transactional sort of guarantees that you would expect from a database, both across execution of your logic, as well as the things that you're storing in memory, right? They're going to be there, just like a database. You don't need to worry about them disappearing because you're programming against this invincible machine that Golem provides you with. It totally alters the way you build systems. So it's the opinion of me, and I know the guys at Restate and a number of other people working in this space, that even though event sourcing is not necessarily going to go away, it is going to disappear from the realm of application developers. It will go into tools like Restate or Golem and whatnot, and it will be used to implement and provide some of the features that these durable execution platforms offer. But you as a developer will never have to see or interact with anything like Pulsar or Kafka or Event Store DB or any of the other solutions out there in this space. Maybe you can plug those in the back end of something like Restate or Ingest or Trigger, or Resonate HQ has some stuff, and Golem obviously has some stuff. Maybe you can plug these different event stores into these systems, and so they are still relevant in that way, but they're not relevant in the sense that if I, as an application developer, go in to build some new system, I'm not thinking about event source architecture anymore. That's gone. That's done. I don't think about that. I just think about writing simple programs that talk to other programs, maybe in a type-safe way, and the reliability aspects of that, the persistence aspects of that, the event sourcing requirements that go into building a solution like this are all handled for me by the underlying durable execution platform. And then, Adriel, you also mentioned actors, and that's actually a great point. So actors provide maybe a foreign way for people to solve challenges in distributed systems programming. But actors, if you have like actor durability, so if you have durable actors, like Orleans, the Orleans project, or Akka cluster with persistence, if you get durability out of your actors or entities, whatever you want to call them, then these entities can execute reliably, even in the presence of failures of individual nodes, and they have state associated with them, and they have business logic. That's basically what an actor is. It's that combination of state and logic. And some actor systems are able to make that actor invincible. So it's always going to be running somewhere, and you don't need to think about failure, recovery, and whatnot. And a Golem provides you with, we don't call them actors, we call them workers, but a worker is basically an actor. If you squint, then basically a worker in Golem, it has a public API that you can call into it. That's kind of like sending messages to actors. And not only does it have this public API, but it has internal state, and you have durable guarantees about this state. It's always persistent. It's going to be always there no matter what happens. So it gives you this like invincible actor model. So if you've done actor-based programming, then it's very easy to understand a worker as a type of actor that has a public API and has its internal state and is going to live forever potentially. And that's one way to conceptualize Golem. And certainly we intend, and people are already using Golem for actor-based use cases. But unlike traditional actors, these actors are written in any programming language. Right? There's no API, there's no SDK. It's just write your Rust code or Go code or whatever, have some public set of functions that you can call into, and those become the messages to your actors, and all the state that's local to that running instance or process or worker that becomes equivalent to your actor state. All right, so Deepa asks, what are your thoughts to support nets in Golem? I think that would be great. I personally am not going to be doing that work, but supporting nets would be phenomenal, and also figuring out a way to achieve compatibility with other WASM-based platforms like WASM Cloud. WASM Cloud's not focused on durability. They're more focused on traditional stateless microservices, which is another really great use case for WASM, by the way. But we're focused on durability, and I know they use nats, and having nat support in Golem could open us up to topologies like edge-based topologies and whatnot, heterogeneous computing environments that are not as easily supported right now. Right now, we're like Kubernetes. You have a Golem cluster. You run that using Kubernetes in some cloud provider and whatnot. But eventually, we want to think beyond that. We want to think in terms of cross data center, edge topologies, heterogeneous compute environments. And NATS is really a better fit for that than what we're using internally for now. Rule asks a question, which is, can we send pull requests before October 28th? All right, so we can't stop you from sending pull requests before October 28th, but we're not going to merge anything until October 28th. So the danger is if you open up pull requests on October 15th, a few days from now, you've got this figured out, you've got to implement it. You open it up in a few days from now, then the danger is someone sees that, copies it, uses AI to, blur the fact that it's actually the same solution, and then they submit that as their own solution come October 28th. So for that reason alone, I recommend don't submit your solution until October 28th, and only submit it after you have zipped everything up and sent it to me in an archive, so that in the event anyone does later derive something from your work, we can catch them and we can make sure that you get credit for authoring that solution. The PRs will not be reviewed prior to October 28th. So if you submit them, we're not going to look at them at all in any way until October 28th. And we certainly won't merge them. The soonest we will merge a pull request is on October 28th. And we may, in fact, if one is ready to go, we may merge it October 28th. Another question from CM Welsh. Since Golem code is durable and can run a long time, how does it know when to go to sleep and when to wake up? Yeah, that's a great question. So if something explicitly goes to sleep and says, I want to sleep until next week, then we'll see there's no point in keeping that in memory. So we will unload it, and we will make a mental note sort of to reactivate that later. But also, there's the inactivity timeout, which applies to all workers, which means that maybe your worker is not sleeping, but it's not doing active work, right? Workers, unlike AWS Lambdas, which only have a very simple sort of input-output interface, workers in Golem can expose a whole API. So you can actually call into specific workers and you can give them instructions to do things, or maybe you can query them and get some information out of them. So workers are designed to live forever, but also we don't want them to consume resources. So what happens is Golem, the worker executor service, it looks and it waits, and if some worker is not doing anything useful, it's just waiting around for more instructions or commands for some period of time, which is relatively small. I think it's on the order of so many seconds, 60 seconds or 120. I don't know exactly what it is, but there's some sort of timeout in there. Then it unloads that from memory and it waits until that worker is reactivated again in the future by a command or query. So in this way, your Golem cluster only contains active workers, stuff that's actually being productive. And all the stuff that's not productive now, either because it's waiting for some point in the future, like you want to send an email in 2 weeks from now, or maybe because it has nothing to do. No one's giving it any instructions. So all of that stuff is unloaded from memory And ultimately, it's pushed off into long-term persistence. Workers never die in Golem. You can't kill workers. I mean, you can actually. There is an API for that, but it's kind of a joke that no matter what you do, you can't kill a worker. It's always going to keep on coming back. And basically, we're trying to make it so incredibly cheap by compressing and rolling stuff off in multi-tiered storage, eventually pushing to S3 or maybe even something that's cheaper than that, have the ability for you to keep stuff around forever and reactivate things when necessary, either for debugging or analytics, or maybe because you want them to do more work, etc. There's another question, which is from Radu. Is this an individual dev task only, or can we collaborate in a team of two? Yeah, this is an individual task. This is a task for one person. Now, that said, I can't stop people from working together as a team and then submitting it as a single person. So if you choose to do that, I would ask that you be honest with us about that. Because if you do work as a team, it's not fair to compare you with all the other people who are working solo. And so you're not going to get a job offer out of that, but you could still win the bounty. Now, I totally believe that this is an amount of work that one person can finish in this time, right? So you don't need a team to get this done in 2.5 weeks. One person is enough. That said, using a team, if you work smartly and work together, well, obviously you're going to get it done in 2.5 weeks. Just be honest with that. You are responsible for dividing that $15,000 bounty. If we award it to you, then it will go to that person who submits the pull request, and they are going to have to be responsible for splitting that up among whoever participated in that. That's on you. We can't help you with that. And if there's any disputes with that, that's your problem. You know, that's what you get for collaborating with people that you don't trust. Just be honest with that, because in the event that a team does work to submit a pull request solution, we will not be extending job offers or conducting interviews with you. So all the solos who end up building a solution on their own, and submitting that as a pull request in the amount of time, we want to talk to you. We want to interview you for a job. And if we don't hire you now, we might hire you in the future, if you're interested and excited about what we're doing here. So we want to talk to all of you. But if you do it as a team, then it's just not fair to compare your work in a team with all the solos who are doing it by yourself. So we would not even try to hire you in that case. And then Eba says that he's preparing a detailed docs for NAT support. Well, that's cool. That's not related to this ticket or this bounty, but nonetheless, that's super cool. And then we have another question, which is, you mentioned that these Golem workers can retry in failure state out of memory error. Yeah, that's right. So for example, ordinarily, if you have a server that's running and one of your request handlers or one of your request handlers for a given request ends up allocating too much memory, you might have a server out of memory error, right? It might take down the whole system. And we try to isolate workers. They're totally isolated because we're using WASM. We have very strong security guarantees. Basically, workers can't talk to each other. And the crash of one worker cannot affect the crash of another worker. But still, there might be scenarios when our server, goes down. Might happen. Catastrophic error, bug in Golem, or maybe a bug in your code that wasn't appropriately sandboxed. I don't know, but there are still things that can go down. Those can be recovered. So in Golem, if this server were to die because it ran out of memory, it'll be recovered, and all those running workers will carry on from where they left off prior to the failure event. And you won't have to do anything. All of this just happens automatically behind the scenes. And then another question, if the failure state is copied over to a new worker to begin executing, wouldn't it still fail? Well, I think that depends. It depends on what the unique set of circumstances are that triggered that failure event. And right now, Golem does not have great support for recovering from bugs. So if you have a bug in your process, then even if Golem tries to retry that, it's probably going to lead to the same result, right? So that's not going to be something we can help you with yet. However, that said, Golem does, at a deep level, have the ability to do time travel, so we can rewind a bit and we can let you update the logic of that running application and then let you resume that. We already support update. So if you have a bug in running workflows and you've not hit that bug yet, so there's still time, then you can update the logic of these workers as it's actually running and fix that bug so that they don't end up in the same place. That's what we have today, and it works. It's great. What we will have in the future is the ability to do a little bit of time rewinding. Right? You know you got into a failed state. It's because of a serious bug in your app, and we'll let you rewind, then update the logic of that worker, fix the bug, and then play back from that point in time. That's incredibly cool, and it gives you the ability to do things that you can't even imagine doing in most applications. You can do that with event sourcing, right? Because you always rewind in a fully event sourced app. You can always rewind, reset stuff, and so you have the ability to not lose work in progress. But we're going to give you that ability in Golem systems as well, using easier, higher level paradigm, which is just I want to back my program up a bit, update the logic, and then replay it from that point. And let's see. Last question is how many people participated in the last hackathon? I don't know. I know we had in the last hackathon. By the way, this is not a hackathon. It's not really a hackathon. It's happening during October. So it's Hacktoberfest. So it is time for hacking on open source, but it's not really a hackathon. It's more like it's an open source ticket that has a bounty on it. And so it differs from a hackathon. In a hackathon, you might have one winner, but the stuff that you're doing is not generally like it was building the Twitter app basically on top of Golem in the last hackathon. And there were lots of people working on that privately. We ended up getting 6 solutions out of that. And then we had three prizes for that, $3,000, I think $1,500 and $750 for that. And that was just to build something on top of Golem, not to actually contribute. So this is the first time when we're trying to invite people to contribute on Golem's code. And Golem is not a simple application. This is like asking people to contribute to a database or to Kubernetes or something like that. So it's not in user land. It's in infrastructure land, cloud infrastructure land. So there's a certain amount of complexity that comes with when you're building distributed systems infrastructure for other developers that maybe a lot of application developers have not yet had the joy of working on. But it's a really fun project. If you like computer science, if you like distributed systems engineering theory and practice, you're going to like working on this project. Michael asks, Golem has done, yeah, so Golem has not done bounties like this, but other open source projects that I manage have done a lot of bounties. An example is Zio. So we've done 60,000 plus worth of bounties for Zio. This is our very first bounty for Golem. So we'll do more. We're going to do a lot more of these over time, but this is the first one. We wanted to go out with a bang, so hence our biggest bounty ever, $15,000. Yeah, we've hired people who completed the bounties for Zio, and I think we've tried to hire more than we actually could hire. But anyway, we'll be making an announcement about someone that we're hiring directly as a result of their contribution to Zio and participation in the bounty system. Rule asks, will there be plans to implement some CRDTs along with the existing protocols such as Raft as one underlying consistency model in Golem? So that's an interesting question, which is what sorts of distributed data structures might you want to share across lots of workers? And we've not done a lot of thought or spec work for that. Obviously, people can build on top of Golem, and we expect that they will. In fact, you could probably take a lot of CRDT logic and compile it unchanged and have it execute on Golem today. I think there is space for something there because workers want to have typed storage, and maybe if it's eventually consistent, it enables certain use cases in local first, where you might want to have a worker executing on a phone or on a device at the edge, but then, pull that worker back into the cloud and let it move to another device. And I think local first applications for Golem are not on our roadmap, but there's obvious fit there. And some sort of CRDT solution might be useful there, but there might be other applications for eventually consistent data structures that are implemented on top of Golem. We just haven't thought about it a lot. For now, you can store anything in memory in Golem, and it's going to be there. It has every bit the same guarantees as a database. So you can use things like maps and whatnot to store critical, business critical information and rely on it being there. Nabil mentions that a great way to boost visibility of the Golem project is to watch on Twitch. Yes, so follow this stream on Twitch if you're not already. And then Christine has a link to the previous hackathon. And then a question from Dr. Professor Sergeant Major Jr. Nice name there. How does Golem make money in general? So we don't. We don't make any money. However, we will be offering a cloud version of Golem. So the open source is great, use it. But I think a lot of people these days, they don't want to have to manage infrastructure. They don't want to have to work at the level of AWS or some other cloud provider. They're just looking for some solution like Vercel, where you sign up and you have this high level GUI and you never have to worry about keeping things running or scaling them up and down or updates and upgrades or compiling from source and all of that. And so how Golem will make money at some point in the future, we're not in any hurry to make money. But when we do make money, it's going to be by offering Golem Cloud. So it's Golem, but in the cloud, and you don't have to do anything, right? You don't have to lift your finger. It's just there. It scales. It's reliable. It's updated. It's patched. It has nice UI and so forth. So it'll still be there in the open source edition. You're more than welcome to host it yourself on-prem or whatever. But a lot of people don't want to do that, and that's where we think that we'll make money because there's just a big market for serverless solutions these days and managed offerings. That's the way a big chunk of the world is heading, and we'll try to capitalize on that when we launch our cloud offering. Optimistically, I would say we'll launch that in 2025, but towards the end of 2025. Steve asks an interesting question. What's the conceptual difference between a worker and a smart contract? None, except because there's a big overlap behind smart contracts and Golem, because you can reproducibly execute a Golem worker, right? There's this log which you can in theory audit and you can verify and whatnot, and other people can verify that that computation would yield the same result under these cryptographically verified responses from third-party systems. It would be, I think, possible to use Golem to build a blockchain with smart contracts. But that said, there's a missing component there, which is the cryptographic piece, as well as the sort of staking mechanism. Is a proof of stake or is a proof of work? You would need to build that thing if you wanted to make it decentralized. If you didn't want it to be decentralized, you would only need cryptographic verification of third-party responses. And then you could verify that, okay, that API did in fact return this result. We know that because it's signed. So all we have to do is verify the chain of computations that produced this smart contract result and the interactions. And you could do that. We don't do that cryptographic verification piece and won't, even though other people could build that on top of Golem. And then the other piece would be is if you wanted to build a decentralized blockchain that can execute smart contracts, then you need some sort of a proof of work or proof of stake or something similar in order to guarantee you don't run into the double spend or cheating. All right, so I think we are caught up on questions, which means it is time to dive into the specification. So I am going to share my screen again. And here we have it. All right, so workers in Golem are instantiated components. So a component is a building block of your application that you've compiled to WASM. And every time Golem spins up a new running instance of that component, it's called a worker. Workers have public APIs. You can call into a worker and you can give it a request and get a response, or you can tell it to do something, or you can, if you're using workers for actor-based use cases, you can send them typed messages and they can do things internally or give you responses. Workers can also talk to other workers, which is quite useful. And we have a number of really interesting open source projects built around that worker-to-worker communication facility. Workers also have state. They have in-memory state. And this is the thing that Golem makes durable. So everything stored in any sort of variable, whether it's a local variable or a global variable, inside your running worker is persistent. And it will survive any fault. You don't need to use any kind of special API. Just everything you store there is persistent and as reliable as a database. Golem workers also have environment variables, and you can use those to provide configuration to workers. And they also have a file system. So every worker actually has its own local file system, which is also persistent and durable. You don't have to worry about the information in that file system disappearing. Right now, in the Golem platform, every time you launch a new worker or a new worker is created, perhaps because some endpoint was hit, so if you trigger worker creation based on API endpoints, then every time you hit an endpoint, it might create a new worker or it might talk to an existing worker. These workers start their lives with an empty file system. There's nothing in it. And the worker is free to download files or database information and whatnot and store that locally in its file system. And there's no problems with that. That already works. However, that does not satisfy all use cases. Because sometimes, let's say you're building a worker and you want it to actually have a database that's local to that worker. Or you want it to have a configuration file. Or maybe you want to use your worker for serving a web app. This represents a document, like in Google Docs, for example. You could have one worker per Google Doc, and that would provide a place to store the contents of that document. But it would also provide an API to mutate that document so multiple people could edit that in real time. So in these cases, you probably want to ship your worker with an initial set of files. And that's what we call the initial file system of the worker. It could be a SQLite database. It could be configuration. It could be, a whole web app with static CSS and HTML and JavaScript and other stuff. It could be any of those. And so what we want to do is, as part of this ticket, is to add support to Golem for every worker having an initial populated, non-empty file system with content chosen by the developer. So that's what this initial file system ticket is all about. And you can see here, there's some use cases. You want to store CSS, HTML, JavaScript. You want to store images or videos inside every worker so you can serve that in some cases, or maybe just configuration data, databases that can be stored in simple files like SQLite, or maybe you have a interpreted programming language like Python or JavaScript or something, and you want to store information that needs to be read and executed dynamically, which is not something you can do on Golem now, but that will become possible at some point. So these are some of the use cases that are motivating our desire to populate that initial file system for every worker. Now, workers are created from components. So the file system is really associated with the component. And then when that component is used by Golem to create a new worker, which is a running instance of the code of that component, then that new worker will, when it looks and sees what exists in its file system, it's going to see that initial file system set. And furthermore, we want to be able to do this efficiently for static assets. So static asset would be these big binary blobs of data like PNGs and JPEGs and MPEGs and whatnot, these assets that you want to serve uniformly from a bunch of different workers. Like maybe every time an API is hit, you serve up static resources, static assets like videos or audio or whatever. And we want to do this efficiently. So that imposes some requirement on the way this initial file system support is to be implemented. It can't be implemented in the simple, naive way, which would be to spin up a worker and then to copy all of the data into the worker's file system. That's not going to work. It would slow things down. But in addition to slowing it down, it would mean that every single worker had its own copy of all these static assets, and that doesn't make sense. It would be hard to make that very fast, to use like an edge network for pushing out content, static content to the edge. It would be hard to do that if every worker had its own copy of all of that heavy-duty binary data. So we don't want to do that. That's going to impose some constraints on the way we solve this. That leads actually to the development of this concept of a permission. Basically, when you define the initial file set associated with a component, then every file in this initial file set needs to be able to have a permission. And that permission is going to be read-only or read-write. If it's read-only, then it's not allowed to change for the life of the worker. So if the worker tries to open that file, it has to error out. It has to say, no, this file cannot be opened in write mode. But importantly, if you say this file is for read-only content, we only have to store that file one place in something like S3. And we don't have to replicate it across all the workers. We can just make a note, a little bookkeeping note, that every time this worker looks at this file, we're going to actually look at S3, and we're going to pull the file contents from there, and we're going to pretend that the worker was storing it locally when in fact it wasn't. And we can do that safely because the contents of the file are read-only. That's going to enable us to achieve tremendous savings in the amount of space necessary to store static content that is never designed to change from inside that worker. In addition, that also, even though this is not part of this ticket, that opens the door to us using a CDN for hosting read-only content. It makes sense, right? If we have read-only content, pushing that to the edge makes sense. That way a worker has ready access to that, and that information can be served directly at the edge without having to go through your cloud system. The other permission is read-write. And read-write basically means that even though the worker should be able to read the contents of that file and get the same thing back as was associated with the component in the initial file set, the worker is nonetheless free to open that file for writing, so they can make changes to that. That could be tremendously useful if you want to ship your workers with a starter database. You're using SQLite and you want a starter database in there so you can, like, it has initial set of tables and whatnot, and you're going to make changes to it over time. Makes perfect sense. You would want that SQLite file to be read-write. That way you can read it and the worker can write it, and its state can diverge from however it was in the initial file set associated with the component that worker was created from. Another implementation note is that I mentioned earlier that Golem actually supports this ability to update the logic of your workers at runtime. You can say, oh no, there's a bug in my running workers. I'm going to do a hot update on them. And I'm going to replace their logic by new logic. And Golem supports that in two different ways. However, because of that, because you can hot update a worker from one version of a component to another version, there exists the possibility that different versions of a component have different file sets. So what do you do about that? Well, it's possible for us to allow certain types of safe updates, right? If you upload a new version of a component that changes read-only files, then we can allow workers who have been updated to that newer version of the component to get access to the latest version of these read-only files after the point of the update. But if you have a read-write file, then it's not a safe thing to do to clobber the user's read-write file with newer versions of the initial file set after a running worker has made changes to those files. So you have to think about that when you're integrating the initial file system feature with a live update, because you've got to do things carefully. And it's all spec'd out here. If you have any questions on the spec, you can go ahead and post that to the ticket and I will get back. That moves us to the implementation guide. So we have an implementation guide that's designed to guide you towards success as you implement this ticket. Shows you roughly the high-level parts of the Golem code base that need to be changed. You're going to need to be extending this Golem manifest file, which is designed to describe right now, the dependencies of your Golem component, but you're going to be extending it so that it can also describe the set of initial files as well as their permissions. Then you're going to need to update some REST APIs that Golem has implemented, particularly around API definitions and component updates. Every time you update a component now or create a component, you get to specify the initial file system as well as permissions for every file in there. So the APIs have to be updated. And then in addition, when you create new API definitions, then there's going to be a possibility to specify a way to serve static content that that worker is hosting. And I'll talk about that in a second. Then the Golem command line interface, Golem CLI, is how you administer your Golem, whether it's locally or whether it's on your own cloud. You use Golem CLI, or you can use Golem CLI just to upload components and update components and create new workers and talk to workers, give them commands or queries and so forth. So you use Golem CLI as you're building your Golem application. And we need to update that so that it's actually going to read that Golem manifest file. So every time you do a deployment or whatever, it's going to read that manifest file. It's going to see the initial file set. It's going to bundle all of that up, and it's going to send that to the REST API. So basically, your modifications of Golem CLI will involve in supporting your extended Golem manifest format and using that to determine what the initial set of files are, bundling all those up, and then sending those to the modified REST APIs that you modified in the preceding step. Worker Gateway. So Worker Gateway is a component in Golem that allows you to put a REST API in front of your Golem workers. And so you can say, this is my endpoint, and when this endpoint is hit, I want to either spawn up a new worker or maybe talk to an existing worker and delegate the request to that worker. So this is how you create public REST APIs for all of the components that you've created and deployed to Golem. You do that using the Worker Gateway. And how we want to support static content there is we want a new type of way to bind an endpoint to static assets that are going to be stored in some worker. And this is going to permit you to serve a website from a Golem worker. Among other things, this will permit you to serve a website from a Golem worker. And then finally, the worker executor needs to be modified because it's got to do some bookkeeping, because it needs to know that for read-only files, if the worker tries to read this file, then it does exist. And we know that because it was part of the initial file set of the component version it was created from. So we've got to allow that read to succeed, and we've got to grab its contents from S3 or wherever it happens to be stored. But then also for read-write files, the worker executor when it creates a new worker, it's got to know, oh, we have these 5 read-write files. We have got to create them inside of the worker's file system. And that way, and we've got to make sure that they're preserved, so that if that worker is unloaded from memory and reloaded from memory later, those files still exist. And then at that point, when the worker talks to those files, when it goes ahead and tries to make updates, those will be preserved automatically by the ordinary durability mechanisms that are already built into Golem. All right, so drilling down into each of these sections in slightly more detail, the Golem manifest file is just a YAML file, and right now it's only supported in a pull request here. So this is where you're going to find these specifications, such as it is for the Golem manifest file. You are going to make sure that whatever you build into Golem CLI supports this, but also extends it in this new way. And this is our proposal for what that looks like. Basically, here's the component name. And inside properties, there's files. And inside files, there's a list of paths and permissions. And so when you build this into Golem CLI, whenever there's creating a new component or updating an existing component, Golem CLI will read a file that looks like this, which is stored inside that component directory. And it's going to say, oh, now I need to collect all these files. And these files are probably local, but some of them might be remote as well. If they're remote, I need to download them. I need to bundle them all up, and then I need to submit them to this new REST API. And you can find links to lots of resources here. So there's 3 APIs that need to be updated for the REST API component. There's the component API, the worker API, and the API definition API. That's fun to say. API definition API. The API for API definitions. The component API. So right now, the component API has an endpoint for creating new components or new versions of a component, and an API for updating an existing version of a component. And what you need to do is modify both APIs to support that initial file set together with permissions. So it's not just the files. Remember, every file can have one of these permissions, either read or read write. And we need that for performance reasons and efficiency reasons. We need that permission flag. So you have to come up with a way to encode that in the API. Right now, the API for creation is multi-part form API, so that's fairly easy to extend. The one for update just expects the new component binary. That needs to change to be a multi-part form, probably update for compatibility with the creation API, just so you can specify more than just the binary. We not only need the binary of the thing, of the component, the code for the component, the compiled code for the component, but now we also need the file set. And not only do we need the file set, but we need the permissions for the file set. So there's different choices on how you might encode that. And some documentation, some guidance is provided there. Updating the worker API. Right now, the worker API does not expose the file set for the worker. So there's no way to call into a worker and say, give me your files. When you update this API, there now will be a way, and you'll be able to enumerate the file system as well as retrieve particular files. So this involves adding 2 new APIs to the worker API, just following the existing conventions and so forth. The API definition API is the most complicated update. There's a number of different things that have to be supported here. An API defines a bunch of routes, and every route has a binding to workers. Well, what we want is a new type of binding, which is called a file server. And this new type of binding called a file server will, instead of ordinarily, when you make a binding, it's going to call a worker function and take the response and convert that to JSON and give you back that as the result. Okay, so that's how you define REST APIs in Golem, is you have your API definition, it has all the routes, and you specify in there how you call into your workers using rib. And so you have little rib scripts or snippets, if you will, that call into your workers and define how you map the input request to whatever the worker API expects, and how you take the output of that and map it back to a response. You don't have to do anything fancy there. You can just let Golem sort of figure out what the JSON structure should be for input and output, or you can be very fancy and you can perform a lot of remapping. If your workers don't really have the right API for public consumption, then you might have to do some data mingling in there, and you can do that. But all of that is ordinary endpoints. We want you to be able to add a new type of endpoint that uses a different type of binding, and this different type of binding is called file server. And for file server, we expect that the script that you use for the binding will inside there, I don't know if you can see that because it's wrapping, it's inside there, it's going to basically give you a file, basically. It's going to say, okay, well, when this endpoint is invoked, then we want to return this file statically from the file system. And so once you specify this type of binding, then the worker gateway is, instead of calling into this worker function, getting back the result and wrapping that up into a response, it's going to call into the worker function, it's going to get a path, and it's going to serve that path from the worker's file system. So it really is just a new type of binding that's, instead of designing to execute logic per se and return a result, it's designed to execute logic which produces a path, and then it will serve that path in the static file system. What this allows you to do is, in your component, you can build a one line of code file server. And that file server just needs to, actually, you don't even need a line of code, right? You really don't need even a line of code. You don't need to write any code in your component. You can just inline in that rib script, you can specify what file to serve. But you could also do that inside your code. And if you choose to do it inside your code, then maybe you decide to restrict what sorts of files have to be served or whatever. It gives you the ability to wrap logic around the file serving process. So there's 4 parts that need to be updated whenever a user submits a new API to be created. Then it needs to be able to support this new binding type. And then when they update an existing API, it needs to be able to, they need to be able to change that binding type to a file server if they want to, or add new endpoints that use file server. And then also when someone reads an endpoint, they need to actually be able to get this information that this binding type is file server. And then finally, when we support importing an API from OpenAPI. And to do that, we use a few extensions that specify how you want to bind each endpoint to different workers that are running in Golem. And so it's expected that the OpenAPI import should continue to support the existing binding type, but also support this new binding type of file server, because it's possible in your OpenAPI definition, in your OpenAPI spec, you want this particular route to serve static assets, which you expect to be inside a worker. So you should be able to do that. Golem CLI needs a modest update, which will involve reading that Golem manifest file, bundling together all the files, and submitting them to the REST API on component creation and on component update. So those are the 2 different command line subcommands that need to be updated. The worker gateway needs support for this new binding type. So just changing the structure of API definition and how that's stored and all the different APIs won't actually add support to the worker gateway for this new binding type. So binding types are interpreted in the worker gateway, called the worker bridge or worker service, and that needs to be updated. And it needs to be updated so that whenever the worker gateway is serving an endpoint that is bound using the file server type that instead of executing the normal logic is going to execute new logic. It's going to expect that that rib script that it's executing give it back a file path. And it's going to use that file path to determine which file in the worker's file system to serve statically. And it will also use that to maybe add a MIME type to the output, right? Or maybe infer a MIME type if the user didn't specify the MIME type, then we should be able to infer that from the extension of the file that the worker gateway is serving. So this involves the worker gateway talking to the worker executor, getting back the right file. First, it gets back the file name, then it talks to the worker executor to get the file contents, or maybe it talks to blob storage if it's a read-only file, and then it serves that up to higher levels that exist above the worker gateway. And then there's some specs on what this should look like. There's some links to source code. And the final component that needs to be modified is the worker executor. The worker executor is where the really hard, at least where a lot of the really hard parts of Golem are. It's actually responsible for executing workers. And it provides these sort of host environment that every worker executes in, which has file system and environment variables and sockets and HTTP requests and all that fun stuff, the environment that every worker has access to through WASI. And there's two things that need to be changed inside the worker executor. Number one, presenting the initial file system. So when the worker first looks at its file system, it needs to see that it's not empty. And that happens through two different ways. The first way is bookkeeping notes that say if it's a read-only file, let's just pretend it's here and let's read it from blob storage. And then the second way is for read-write files, actually populating that local file system so that it contains the contents of those initial files. And then at that point, the worker is free to change them. Note it should be an error, obviously, if a worker attempts to open a read-only file. That should result in the appropriate error type. And you can look that up in WASI. You can find out what it's supposed to be, and you just return that error type if the user tries to happen to open one of these read-only files for modification. And then the other part here that it needs to do is it needs to expose the worker file system. And the reason why it needs to expose, basically, it needs to expose the worker file system so the worker gateway can call into the worker executor and get the files that it needs as part of supporting this new file server binding type. So that means a new gRPC API. Basically, gRPC is used for the worker executor to talk to the worker executor. So right now, the worker gateway already talks to the worker executor. Lots of things do. It's all through these gRPC APIs. We need a new one that exposes the file system for a worker. And this new API will end up being used by the worker gateway whenever it is serving one of these routes that is using the file server binding type. So that's how it's actually going to get the contents that it needs. It makes sense to put that there. And the reason being, the worker executor, the right worker executor for a specified worker is going to have the file system for that worker. It's going to have access to it. It's going to have exclusive access to modifying that file system. So it's going to be consistent, up-to-date view of the file system of that worker. So at least for read-write files, it makes sense to always go through the worker executor. For read-only files, the worker gateway can take a shortcut. It knows that those files don't change. It knows what component version there is, or at least it can look that up. So it can actually go to blob storage, and it can serve the content directly from blob storage rather than having to go to the appropriate worker executor and call its gRPC API to stream out the contents of the file. It doesn't need to do that. But at least for read-write files, the worker bridge, worker gateway has to talk to the worker executor through a new gRPC API that you will add as part of your changes to the worker executor. And then the last bit of documentation here is the note on integration testing requirements. Obviously, the existing code has lots of unit tests, and you should write unit tests for your own work. But there are 3 separate levels of integration tests in Golem that are designed to catch different types of bugs. And it's important to add some tests in all 3 layers. The first one is the worker executor tests, which directly test worker executor. So as you're modifying the worker executor and adding support for presenting the initial file system and this new gRPC API, it makes to test that directly at the level of the worker executor. But then also integration tests, they start services of Golem locally, and they have access to a little test DSL, which we wrote, to upload components and to run tests on these components and create workers and whatnot. It makes sense to test it there. That integration test project can cut across all of the different areas that you modify, not just the worker executor, but everywhere. And then finally, we have separate tests for the command line interface. And those tests have to spin up everything, and they do. They spin up everything, but they also test how the command line application interacts with the REST API, and then how those REST APIs end up delegating to the different, generally gRPC services on the back end. So it's basically an all-in-one test that touches the user touch point, the developer who is using that command line interface. We need to guarantee that these commands for creating a new component with the file system, as well as updating an existing component with maybe a slightly different file system, we need to guarantee that that end user tool actually works and functions as specified. And so adding a few tests there to test the different scenarios, you're creating a new component with a file system, you're updating an existing component with a new file system, to test that those work from the CLI, we'll end up testing the whole stack. And that's the last level of tests. And as for how many tests to add, use your judgment. But obviously we are looking for a level of coverage that is roughly equivalent to the existing level of coverage for the unit level and the 3 levels of integration tests, as well as any system tests you might find in any end-to-end like benchmark or whatever. Okay, so that is the presentation of the specification. And if you have any questions over any of that, and probably you don't even know enough right now to ask questions about some of that, and it's going to take you a few hours or a few days to get that far into the project, depending on your own scheduling constraints, to even have questions about some of these areas. But if you do have questions about the specification itself, that is, you want to know whether this solution or this solution would be acceptable, or if you have to make this choice down here, whether this format or this format, or you want to know what sort of multi-part form API is going to be considered acceptable, etc., then definitely ask those questions, but ask them on the GitHub issue for this ticket. And I will answer them there. Don't ask them on the Discord, because that's just going to scroll up and people are never going to find that. So for purposes of visibility, please ask any spec-related questions on the GitHub issue itself. And those are the only type of questions basically that we're going to be answering. So one more thing I want to show you before I take a final round of questions, and that is the initial file system. Here it is in all its glory. It is ticket 1004. And you can see I have tried to recap all the information I've covered in this presentation today, and you can download the PDF specification that I was looking at. It's possible, if I have to clarify enough things, or if there's any bugs in that spec, that I might have to update that spec. I will do that in line. And I will also make a comment here saying, I had to fix a bug in the spec, I had to clarify something, there's a new version of the spec, get it here. You can also find the timeline, the structure, the rules, and shortly you will be able to see the $15,000 bounty. I was not able to configure that in time for this kickoff event, but I will be on that right after this event. I will be configuring that, and you'll be able to see that Algora will have a $15,000 bounty associated with this event. We use the Algora platform for all of our bounties, and you can go on there and you can see algora.io. You can check out all the bounties we have across all our projects, and future bounties on Golem Cloud, or sorry, Golem will also be posted there. All right, so having walked you through the spec and the GitHub issue, I am going to go ahead and take a last round of questions. Can workers talk to each other directly, or do the requests have to go through some central Golem Cloud server? So the answer is a bit of a mix. Workers can talk to each other directly, but right now it's assumed that that is happening inside the same data center, pretty much, inside a secure area. So that's where something like NATs could be really interesting, because you add NATs to this, and suddenly your workers could communicate across data centers, or even like a worker running on a smartphone or whatever, or on a smart device could be communicating to a worker running in the cloud, could be communicating to a worker running on your desktop. That's definitely part of the long-term roadmap for Golem. We just haven't done that ourselves. So if someone is really interested in working on that, you're more than welcome to help us accelerate the development of that feature. Basically, it needs a networking abstraction in Golem. We need to peel apart the way we locate workers and say, here's our separate routing logic, and here's authentication and whatnot, and have an abstraction in there that will work, yes, inside a data center, the same data center, but also across data centers, and also across devices and heterogeneous compute environments, and in environments with mixed levels of trust. So that's something I think we could use some help with if somebody wants that. Taz Maniacs asks the question, is there a performance hit for durable persistence? Yes, but it's small. We actually have benchmarks, and it's very small. It's amazing, actually, how small it is. And note that if you want to do a commit operation, which is a guarantee that the information inside your worker has been persisted to more than one independent node, right? If you're not just concerned about the failure of the worker node that's executing, but also you're concerned about the failure of the underlying persistence that is backing all of this durability, then you might want to guarantee, or you might want to guarantee from Golem that your code is going to stop here and not proceed until that information is written to some number of replicas. So we actually do have a low-level operation that you can call in the Golem SDK that says, please wait and don't allow the execution to proceed until that replica is confirmed to some specified number of replicas. You can use that if you want. I don't think it's necessary for most use cases, because in order for you to lose information, the worker node would have to fail, and then the primary would have to fail before it had a chance to replicate the backup. You probably don't have to worry about that. And depending on the data store you're using, you might not even have that issue. If you were using something like Kafka to back Golem, or Pulsar or whatever, then even though the writes would be a little slower, nonetheless, you would have the guarantee that once written, it would be fault tolerant, and you wouldn't have to worry about that. Peter asks, what about storing IFS on Kubernetes PVs that support multiple write, multiple read, one write, multiple read, etc.? I think the drawback is that we're trying not to bake in too much use of Kubernetes inside of Golem itself, for the reason that we don't want to be too opinionated about how you deploy Golem. Obviously, we encourage deploying Golem in cloud environments inside Kubernetes, but you can also deploy it using Docker containers on your local laptop. So we're a little bit hesitant, I think, to introduce heavy dependence and reliance on Kubernetes specific features. And in this particular case, I think, you can make a case, I think, that we should be doing that. And if you're able to successfully make that, then okay, we'll listen to that and we'll consider merging your PR. But it might be a little safer to say, certainly I think for the rewrite files, we have no choice. Those have to be stored inside the worker. And the reason is you can write to them, and writes happen through this low-level interface called WASI. So when you compile Rust or Go or whatever, then the standard library routines that open files and modify files, all of those end up delegating to WASI functions that provide the low-level operations. And of course, we want them to continue operating. So what that means is for read-write files, we have to use the worker, the local file system. For read-only files, we have more flexibility. However, we already do have a blob service, pervasive in Golem and accessible and documented with multiple implementations. So all that's there. It could make more sense to use the blob service to store the read-only files, because not only is it there in the source code, and it's already being used to store the components themselves, so it's easy to use that to also store these binary big files, MPEGs, videos, whatever the static content is. You can easily use that, but it is not going to be tied to Kubernetes, so it's going to be less opinionated about how you deploy Golem. There's a question: is the manifest example a hard requirement or a proposal of how it should look like? It is a proposal for how it should look like. But if you encounter problems, or you have a better opinion about how it should be done, maybe you're very opinionated about how that should look like and you think it could be done better, then feel free to propose that. But obviously you're going to be making that case to the Golem engineering team when they take a look at your pull requests on October 28th. So if there's no major problems with what you see, if it looks reasonably good, then I would choose to do that. On the other hand, if you've reasoned several steps into the future and you're like, well, we might want to change the format for these other reasons, and you can make that case, then I think we'll appreciate that. And like the Golem team will definitely appreciate working with a colleague who can bring that type of expertise to the table. So if you see better ways to do something, don't be shy about proposing them. Yeah, you can go ahead and post the document here in chat. Yeah, the PDF. All right, so one last question, it looks like: should writes to read-write files be synchronized to all workers? No, no. So that would be outrageously difficult and not scalable at all. I would not scale, so we would never do that. Every worker has its own file system that is completely independent of the file system of any other worker. So all of the rewrites that a worker is making to its file system are only visible locally. And eventually they're going to be, once you add the new API for browsing the file system of a worker, then obviously they're going to be visible to the outside world, but only in a constrained way through that worker's identity. So if you know that worker's identity, you can go list that file system for that worker, but it's not like these file systems are going to be combined or synchronized in any way. They are completely independent. And obviously that greatly simplifies the problem. All right, I have gotten through all the questions, so nothing else, right? We're at the end, no more questions. Everyone is good to go. Well, best of luck to everyone. Have fun, and I cannot wait to see, come October 28th, what all of you come up with. Remember, if you have any questions about the specification, post on that GitHub issue, and I will clarify all day long to make sure that it's actually clear what we're asking for. If you have questions about how to build it, you're pretty much on your own. But if you participants in this want to help each other figure out the code base or whatever, then feel free to use our Discord to do that. That would be great to see. Good luck, and may the best solution win. I cannot wait to not only see them, but also hire our next member of the Golem engineering team. That's going to be a lot of fun getting to work with